So the first step is to get the mass of the beetle. So here's our scale. It is all at 0, ready to go. So we'll just put the beetle on there. And you can record that value for the beetle. So in order to calculate out distance moved, we're going to use graph paper. So here's a piece of graph paper. This is the graph paper we will use. It's important then to get distance for each of these little squares. So if we go in, we can use this ruler here, get our ruler right on, and we can see that each square is approximately 0.5 centimeters. So we'll say each square is 5 millimeters. Okay. So here are the two of the beetles that we're going to use for this study. You can see they have a nice exoskeleton and they have legs, so they're able to crawl around with those legs. So I'm going to take one of these two, place it in the respiration chamber. Okay, and then we now have the beetle that we're going to get a measurement on, and we'll add the CO2 gas probe to this beetle so that we can get an estimate of respiration rate. So in looking at this setup, I do notice one thing. So if you watch the poor beetle move around, its legs are slipping. Since its legs are slipping, we're not going to get a true measurement of the distance it moves, so it needs a little bit harder surface than the plastic. So I'm actually going to cut out a piece of paper and then secure the paper inside the chamber so that the beetle has to walk on that paper. So I'm basically going to take that, cut it out, and insert it inside. So here we go, we've got it fixed. I put the piece of paper inside the jar now so the beetle's not slipping all around. So I'll attach the CO2 gas probe to it, make sure that it's nice and level on there. Okay. And then it's pretty good, if the beetle goes directly underneath that, then that'll be a problem. But we'll go ahead and acclimate it and then get this started. And I'm going to start this right here. We'll press play, erase, and continue. And our experiment is on. For the camera then, you need to look at the camera and see what's happening for 3 minutes. Except we're going to have to start this over because the guy landed on his back. So let me stop here, and let me stop here. Okay, so now I'm recording on the camera and on the computer both at the same time. I'm going to count down from 3, and then I'm going to say start. And when you start, then start counting how many squares the beetle moves so you can keep track of the distance. Ready? 1, 2, 3, and start. Okay, so now I'm recording on the camera and on the computer both at the same time. I'm going to count down from 3 and then I'm going to say start. When you start, then start counting how many squares the beetle moves so you can keep track of the distance. Ready? 1, 2, 3, and start. Now for the computer, I'm going to stop it and then restart it after 3 minutes so you don't have to wait. You just watch the line go. Okay, so here we go. I highlighted from time 0 here to the end right here. I then took the slope up here, got the value. I'm now going to take a screenshot, and then I'll add the screenshot to the video so you can find the slope yourself.
Help me, help me, help me. I can't get up. I'm on my back.
Now I need to get the mass of the worm. So our scale is zeroed. And we basically just take that worm, put it on there, and then you can get the mass of the worm. Okay, now we're ready to set this up for our worm. So here's our worm. And I'll basically put the worm inside the chamber here. And we'll add the gas probe, if I can do that. And get it all set up where you can see it. We need a little bit of something to make that flat on the top. Okay. And there we go. So we're all set up and ready to go. All right, give this 3 minutes to equilibrate, and then we will run the experiment. Okay, now we're ready to start our 3-minute trial. So ready, set, and go. Start recording distance. Okay, time is almost up. We want to stop recording distance here. When I say stop and stop, that's 200 seconds.